Welcome students to the circuit simulation lab. In this session we are going to study how to write a program for the logical gates. After the completion of this course you are going to be successful in solving, simulate and analyze the various digital electronic circuits. The objectives of this session are: we are going to learn how to write a program to produce a truth table for the following gates: NOT, AND, OR, NAND, NOR and exclusively OR gate. So now let us define what is a logic gate. Logic gate are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and output is based on the certain logical operation. Based on this logical operations, the gates are named as AND gate, OR gate and NOT gate. Now let us study about what is an OR gate. The OR gate is a logic circuit with two or more inputs and one output. It performs the OR operation. It is defined as the output of an OR gate is high or 1 if one or more inputs are high or 1. So this is the logic symbol for the OR gate and this is the truth table for the OR gate, where you can see if both the inputs are 0, then the output is 0. If any one of the input is 1, then the output is 1. The Boolean equation for the OR gate is y is equal to a plus b, or we can also write it as a or b. In the MATLAB, it can be represented as y is equal to or a comma b, or symbolically it is represented as y is equal to a vertical broken bar. The line, vertical line what you see here, it is called as the vertical broken bar and it is present on your keyboard. Similarly, now we will see what is a AND gate. The AND gate is a logic circuit with two or more inputs and one output. It performs the AND operation. It is defined as the output of an AND gate is high or 1 if and only if all the inputs are high or 1. And the logic symbol for the AND gate is given here. A and B are the two inputs and Y is the output. Here the truth table we are having that any one of the input is 0, then the output of the AND gate is 0. If all the inputs are 1, the output is 1. Boolean equation for the AND gate is given by y is equal to a into b, or we can also write it as y is equal to a and b. In the MATLAB, it is represented as y is equal to and a comma b. Y is equal to a ampersand b. This is the symbolical representation, where here a and b are the inputs. Now we will see what is a logic NOT gate. It has one input and one output. It is also called as inverter as it inverts or complements its input. The logical symbol for the NOT gate is given here. A is the input. It has got only one input and only one output. The truth table for the NOT gate is A is the input. Then if the input is 0 or low, then the output will be high. If the input is 1, then the output will be 0. The Boolean equation is written as y is equal to not A. and it is represented also as y is equal to a bar. In the MATLAB, it is represented as y is equal to not a, where a is a input again, or y is equal to with this symbol, and this symbol is called as tilde a, where it is present on the keyboard. Now the NAND gate. The NOT AND operation is known as the NAND operation. It performs NOT AND operation. It has two or more inputs and only one output. The NAND operation is defined as the output of a NAND gate is low or 1 only when all the inputs are high or 1. So this is the logical symbol of a NAND gate, where you can see A and B are the two inputs, Y is the output, and here this is a NAND gate, and here there is a bubble which indicates a bar here. Y is equal to A into B bar. It is just opposite of the AND gate. If any one of the input will become 0, then the output of this gate will be equal to 1. Now similarly, here also the Boolean equations we can write as y is equal to a bar, a into b bar, or y is equal to a NAND b. In the MATLAB, we can write it as y is equal to, since it is a NOT AND operation, so this part indicates it is a AND operation, and since it is a NOT AND operation, so therefore we are going to write here NOT. So NOT AND A comma B, where A and B are the two inputs, and symbolically it can be represented also, where A and B are given with the AND symbol here and then with a NOT symbol. Similarly, the NOR gate. The NOT OR operation is known as the NOR operation. It performs NOT OR operation. It has two or more inputs and only one output. The NOR operation is defined as the output of a NOR gate is high or 1 only when all the inputs are low or 0. Similarly, we can define it in many different ways. Then this is a symbol of a NOR gate. So this is a NOR gate, OR gate along with a small bubble here. So this bubble will perform the NOT OR operation. That is, A and B are the two inputs, and here A plus B bar is the output. So it just performs the opposite of the OR gate. So when one of the input is, any one of the input is 1, the output of the NOR gate will be 0. If all the inputs are 1, the output will also be equal to 0. Boolean equation for the NOT gate is given as y is equal to a plus b bar, or y is equal to a NOR b. In the MATLAB, it is represented as y is equal to NOT OR a comma b, where the NOR gate is just opposite of the OR function. So therefore, here we are writing it is OR. A comma B are the inputs, and then it is a NOT operation, and symbolically also it can be represented. Exclusive OR gate. Exclusive OR operation is widely used in the digital circuits. It is not a basic operation and can be performed using the basic gates such as AND, OR and NOT gate. Exclusive OR gate is a combinational circuit with two or more inputs and one output. It is defined as the output of exclusively OR is high or 1 only when odd number of inputs are high or 1. Similarly, we can define it in the many ways. So this is a exclusively OR logical symbol. A and B are the inputs, and then Y is equal to A exclusively ORed with B. And this is the truth table. When both the inputs are 1, the output is 0. When both the inputs are 0, the output is 0. If any one of the input is 1, then the output is 1. And the Boolean expression is given by y is equal to x or b. In the MATLAB, we can write it as y is equal to x or a comma b. Again, where a and b are the two inputs. Then, let us see now the program number 13, logic gates. Write a program or a script file that produces a truth table for NOT, AND, OR, NAND, NOR and exclusively OR operations. So, we are going to take the two inputs as A and B as the 4 bits. Now, how to write the program? So, this is a clear screen, CLC, that is it clears the command window. Then we are going to display the output. This command is going to display the text output. So, we are having here the inputs of A, that are 0, 0, 1, 1. Since we are having the two inputs we have considered here as A and B, so therefore the number of combinations will be 4. 0, 0, 0, 1, 1, 0 and 1, 1. So, according to that, the values of A and B are taken. So, these are the inputs for B. Now, we have taken a variable called as C underscore naught, where in this variable we are going to keep the NOT operation. That is, NOT operation value, whatever we are getting, we are going to keep it in this variable. Similarly, I have created another variable, that is D underscore AND, which is equal to A and B. It represents the AND operation of A and B. Similarly, E underscore OR is another variable which represents the OR operation. That is, we have written with a symbol A vertical bar B. Again, for the NAND gate, we have created a variable F underscore NAND. Since the NAND performs the NOT AND operation, so therefore it is written as AND AB and along with it NOT, which represents the NAND operation. G underscore NOR is another variable which is created for the NOR operation. And H exclusive OR is equal to XOR A comma B, where it performs or represents the exclusive OR operation. So, here TT is a table where we have created a table called as TT, where it has got A, B are the inputs, C underscore NOT, this represents the NOT operation, this is representing the AND operation, this represents the OR operation, NAND operation, NOR operation and the exclusive OR operation. It displays the truth table, the heading for the truth table. Displays the inputs and outputs as a heading of the table. Then display A, B, NOT, AND, OR, NAND, NOR, exclusive OR. It also displays what? The heading for the truth table. Then display TT. So, it will display what? Now, it will display the truth table for all the gates, where all the gates, the performance of all the functions, that is NOT function, AND function, OR function and NAND, NOR, exclusive OR, all are stored in this table TT, which will be displayed. So, this is how the output we are going to get. This is the output is displayed here. Then the truth table. Then inputs and the outputs. A, B, so this will give you the not truth table, this will give you the AND truth table, and this will give the OR truth table. This gives the NAND, similarly NOR and exclusive OR. Now you can see we are having the two inputs, 0, 0 or low. When both are low, and since I have taken only for A, since A is low, here NOT is also coming as 1. So in the AND operation, when both the inputs are 0, output is 0. In the OR operation, when both the inputs are 0, output is 0. NAND operation is exactly opposite of the AND operation. So when both the inputs are 0, output will be 1. Similarly with the NOR operation. And when both the inputs are 0, exclusive OR is 0. So similarly, we will be having for all the possible combinations of the inputs. So here you can see A, when A is 0, the output of NAND gate is 1. 0, not is 1, 1, 0, 1, 0. Since we have taken it for the A input. So this is the truth table for the AND operation. 0, when any one of the input is 0, it is 0. 0 again, when both the inputs are 1, the output is 1. So similarly for the OR gate, when any one of the input is 1, the outputs are 1. So NAND gate and NOR gates are exactly the opposite of the AND and the OR. And this is the truth table for the exclusive OR operation. Now we will execute the program for in the MATLAB. So already I have written a program where I will just open it in the MAT environment, that is. So this is the program. So it is a clear screen. Then we have displayed the output here. Then A is the bits A 0 0 1 1, B is 0 1 0 1, and we have written the NOT operation here. Then we have written here the OR operation, the NAND operation, NOT operation, exclusive OR operation, and then we have created a table. The heading of the table is given as truth table. It will display the inputs, which are the outputs, and the inputs A and B and the different gates. So now we will run this program. So the name given to this program is gate. Then we will execute it. Then you can see here I am getting the display as output, the truth table. These are the inputs A and B, and these are the outputs of the gate. So this is how the output will be represented for the various gates. And this is the program we are having. Now we will just have some exercises. We have the MCQs. So what is the output of the following code? Exclusive OR and 1, 0 NOT XOR and 1, 0, 0 and with the two brackets. Now what will be the answer? Is it A, B, C or D? The answer is A. It is 0. Why it is 0? And of 1, 0 is 0, and exclusively OR 0 is 1. But exclusive OR 1, 0 is 1. Hence not exclusive OR operation 1. So therefore it will come to 0. The second question. All logic operators operate on at least two operands. Is it true or false? Yes, the answer is B, because the tilde operator operates, this symbol we call it as the tilde operator, operates on one operand, but it's a logical operator, hence the statement will be false. What is the output of the following code? Sin pi not equal to 0. What would be the answer? It can be C, it is 1. Why it is 1? Sin pi is not equal to 0, since pi is represented as a floating point number in the MATLAB. If pi was declared as a symbolic variable, the output would have been 0. So therefore, the value of this sin pi not equal to 0 will not be equal to 0, but it will be equal to 1. Fourth one. What is the extension of the script files? What it is? Yes, it is, the answer is A, .m. Script files are a kind of M file. So to save a script file, it has to be saved with the extension as .m. Otherwise also, the MATLAB by the default it takes as the .m. Now the fifth question. What is the basic difference between M files and the MAT files? The options are: there is no difference. MAT files are binary data files, while M files are ASCII text files. Or C is M files are binary data files, while the MAT files are the ASCII text files. There is no such thing at a MAT files. Which may be the right answer? Yes, the right answer is the answer B. What will the following command do? Load M1. Load M1. When we give, what is it going to do? Load the script file named M1. Load the function file named M1. Load the M file named M1. There is no load command in the MATLAB. The answer is C. Load the M file named M1. What will be the following command do? Save workspace. So these are the options. Saves the entire workspace as a MAT file. Saves a variable named workspace as a MAT file. Saves the entire workspace as a M file, or saves a variable named workspace as a M file. Answer is B. It saves a variable named workspace as the MAT file. 8th. Keys combination used to stop the execution of a command in the MATLAB. Key combinations. On the keyboard, which keys you are going to use for the stop the execution of the MATLAB? That is Ctrl plus C, Ctrl plus S, Ctrl plus B, and Ctrl plus Enter. It is, the answer is A. Ctrl plus C. How one can save the MATLAB environment data into a MATLAB data file and call the same in another MATLAB program wherever required? How can this be done? So this can be done that MATLAB programmer can use the save and load for doing the above. The programmer can save and load, either save or load for doing the above function. What is the type of the program files that the MATLAB allows to write? MATLAB allows two types of program files. It is the script files and the functions. It is a file with .m extension. In these files, it writes the series of commands that the programmer want to execute together. It does not accept inputs and do not return any outputs. Functions. They are also files with .m extension. The functions can accept the inputs and the return outputs. So these are the few activities you have to perform. Write a program to produce a truth table for the OR gate with 3 inputs. We have considered it for the 2 inputs. Now we have to write a program for the 3 inputs. Similarly, write a program to produce the truth table for the AND gate with the 3 inputs. What kind of program the MATLAB allows to write? This is the third activity you are having. So, go through these activities properly and then write. These are some of the references books we have used to prepare this presentation. Thank you.